Everyone, this is the video continuation of Newton law of motion. Today we will learn about friction. So this is very important regarding your board exam and for JEE and NEET also. See, if we have any two surface, in naked eye it can be seen that two surfaces are very smooth. These two surfaces are very smooth. Let us say these two surfaces are made of glass. But in microscopic view, if we zoom it, the two surfaces will look something like this. Two surfaces will look something like this. So clearly we can see that though it is made of glass, but it is not actually plane. It has curvical structure due to atoms. So whenever this surface will move in the forward direction, let us say upper surface move in the forward direction, these two curves, this curve will attach to this curve. So this curve will repel this curve in the opposite direction. So every curve will repel in the opposite direction. That's why we have a new name, that is friction, that is opposing force. Opposing force. So if the object moves in the right hand side, the opposing force would be in the left hand side. That is all about friction. Now we have three types of friction: static friction, limiting friction, and kinetic friction or dynamic friction. If you look closely these 6 diagrams, you will understand that we have applied a force F in the left hand side. So our friction Fs is this Fs is actually in the downward side. Fs is in the opposite side. See here. In our case, in this diagram, our body is moving right hand side, so our friction is in the left hand side. Similarly, in this 6 scenario, this object we have applied a force in the left hand side, so our friction would be in the right hand side. In this case, it is also in the right hand side, it is also in the right hand side. So what is the difference between these 6 diagrams? Let us see. Our first definition is static friction, the force of friction which comes into play between two bodies before one body actually starts moving over the other. So if you look closely this three diagram, the object actually didn't move. We are trying to move by applying an external force F, but this curvical structure still able to overcome our applied force, and as a result these bodies do not move. So if you see that this Fs, this vector Fs is small, this is larger than this Fs, and this is larger than this Fs. It is a force, so it's a vector quantity, and you can simply judge by its magnitude. So magnitudically it is largest. That means we are applying the force F, but still we are applying the force F and we are continually pulling the object, but literally the opposing force increasing. And it increases to a maximum opposing force Fs. That means in this scenario our F and this Fs is actually equal. So this is our limiting friction. That means from this situation the object actually will try to move. Up to this the object didn't move, and from this the object will try to move. After that it moves. You can clearly see it has a velocity. Whenever the object moves, it have a friction. That friction is known as kinetic friction. And remember one thing, that our Fs is static friction. Static friction is less than or equals to maximum static friction, that is your limiting friction, and Fk, that is kinetic friction, is less than your it is strictly less than your limiting friction. So this graph is extremely important for board level exam. See here, this is a straight line, this is a straight line, this is a straight line for static friction. That means whenever you can imagine this from these three diagram, we have applied force continuously but the object didn't move, but our Fs increases. So we have applied force, our Fs increases. We have applied force, our Fs increases. We have applied force, our Fs increases linearly. So it's a straight line, and after that, due to heating and atomic interaction, there is a downward curve in the friction, and after that it is constant. Whenever the object moves, this Fk will be fixed during its whole motion. So that's why this is the limiting friction, and this constant friction is your kinetic friction. Now we'll move forward to our next topic. So let us see laws of limiting friction. The limiting friction depends on the nature of the surface in contact and their state of polish. The limiting friction acts tangential. See, any surface, the friction acts in the opposite side, and that is towards the tangent to the surfaces in contact and in a direction opposite to the direction of motion. The value of limiting friction is independent of the area of the surface in contact, so long as the normal reaction remains the same. So that means for any surface, our friction doesn't depend on the contact surface, area of the surface. The limiting friction Fs max is directly proportional to the normal reaction. See, if we put any object, we have, according to our Newton's law of motion, our weight W equals to mg acts towards downward, and action and reactions are same and opposite direction. So we have a reaction force for the surface, and we have applied a force here. For this force, we have in the opposite direction, we have a frictional force. So according to limiting friction law, that is Fs is directly proportional to this, Fs is directly proportional to the normal reaction R, or you can say it as N also. If we omit the proportionality constant, we have to give a constant. That constant is here our mu s, and mu s is known as coefficient of static friction. In the similar manner, we can say Fk is proportional to R, Fk is mu kr. See, here we have mu s, here we have mu k, nothing much difference. Mu k is called coefficient of kinetic friction, and we have just learned that kinetic friction is less than our maximum static friction. So Fk is our mu k into R, Fs is our mu s into R. So R cancels out. So we have mu k, that is coefficient of kinetic friction, is less than coefficient of static friction. See two terms, angle of friction. The angle which the resultant of the limiting friction. Resultant of the limiting friction. See, this is our resultant of the normal reaction force, and this is our limiting friction Fs max. So this is our normal reaction force, and this is our limiting frictional force. So the angle which the resultant of the limiting friction makes with the normal reaction, which makes with the normal reaction. This is our resultant of the limiting friction. This is our resultant. That resultant makes with the normal reaction force. If this is Fs max, this would also be Fs max. So from this triangle we can say tan theta equals to Fs max by R, and in the previous slide we have learned that Fs equals to mu s into R. So mu s would be Fs by R. So Fs max by R is our mu s. So we can say tan theta is your mu s. So coefficient of static friction, that is mu s, is equal to the tangent of the angle of friction. Now angle of repose. If we have something sliding representation, this, it is the minimum angle that inclined plane makes with the horizontal when a body placed on it just begins to slide. So let us say we have a object here, and this inclined plane makes angle phi with the horizontal. So as we have already know that our weight always perpendicular to acts towards the perpendicular to horizontal surface. So our weight from the center of gravity, weight will act in the horizontal direction, perpendicular to horizon. If you extend this, this is the perpendicular. So this is your mg, and if this is phi, this is 90 degree, so this would be 90 minus phi, so this angle would be phi. So this, if this angle phi, if this angle would be also phi. So now this is mg, this is attached component, so this would be mg cos phi, and this perpendicular component would be mg sin phi. Now this surface is attached to this inclined plane, so it will have a reaction force perpendicular to mg cos phi, and as this surface has a frictional force, so we have opposing frictional force Fs max. So from this diagram we can equate the equal component, that is R is equivalent to mg cos phi and mg sin phi is equal to mg Fs max. Why? Because this in this scenario the object is just tends to slide, okay, that's why mg sin phi is balancing with Fs max. So this is, now divide Fs max by R would be tan phi. Now tan phi is your mu s. From this we know mu s is tan theta, and from this we have come to know that mu s is Fs max by R, that is your mu s. So tan theta is tan phi, so theta equals to phi. That means angle of repose is equal to the angle of friction. This is very important. So let us see one problem related to friction. What is the acceleration of the block and the trolley system as shown if the coefficient of kinetic friction, that is this is Fk, is given between the trolley and the surface is 0.04. What is the tension in the string? See, we have already know the FBD, free body diagram, how to draw free body diagram. If you don't know, kindly see our previous lecture on Newton's law of motion. So in this diagram we have to draw free body diagram, that is we have to free every body attached to this diagram. See, we already know that tension, where tension is always towards the pulley, where tension is always towards the pulley. So here tension T, as the wear is same, as the wear is same, so tension will also be same. Tension is always towards the pulley, that is the first point. If the wear is same, tension would be same, that is the second point you have to remember. Now see, here the object is moving in the right hand side and this object is moving in the downward side. As the object is connected with the same wear, so acceleration will also be same. That is the third point you have to remember. Now see, here 30 Newton acts in the downward direction, that is here it is the force, right, or you can say this is the weight, or this is force acting downward. This is 3 kg, 3 into 10, W equals to mg, W equals to mg, that is 3 into 10, that is 30 Newton force is acting downward. Now see, here as the trolley is moving, we don't have here static friction, we have our kinetic friction, that is Fk, and Fk is acting in the opposite side because we have the tire attached to the ground. So this tire will oppose the moving and the friction will be in the opposite side, okay. So here Fk is in the opposite side. Now see, as the tire is attached to the ground, so it will have mg, W equals to mg, let us say this is W1, this is W2, this is mg, that is 20 into 10, that is 200 Newton. 200 Newton is acting downward. As the tire is attached, it will have, from the Newton's third law of motion, it will have reaction force. So these have reaction, these have reaction. We will not take separate reaction because it have 4 wheels, right. We will take together 4 wheel reaction force as one reaction force, that is R. Now this is the basic diagram. You have to redraw it. If you redraw it, this diagram, I am showing one diagram, you have to write another one by yourself. See, FBD, that means you have to free the objects attached. Now here in this object, this is 3 kg object acting downward. So as the weight is force, this weight is acting downward, 30 Newton, and the object is going downward with acceleration A, and here we have tension force T. So this is known as FBD, free body diagram. Okay, we have freed the body from this whole diagram. So if you concentrate on this diagram, we see that the resultant force is acting downward. As the object is moving downward, so its acceleration direction is downward. So from the second law, we can say that weight 30 Newton, that is the force acting downward, T is opposing itself. So 30 minus T is the resulting force acting downward, that is mass into acceleration from second law of motion. Now concentrate on this diagram. The object is moving right hand side, so T is larger, Fk is smaller, So T minus Fk, that is your resultant force. So from second law of motion, T minus Fk should be mass into acceleration. What is the mass? 20. Acceleration is a. Now we know that Fk is equals to mu k into r, and here if you see that here if you see r is equals to mg. So in place of r we can write mg. We know the value of mu k, that is 0.04. We know the value of m, we know the value of g. It is found to be, Fk is found to be 8 Newton. Put the value of Fk here. So solve, now solve 1 and 3, you will get acceleration as 0.96 meter per second square and tension as 27.12 Newton. Let us see another question. We have two blocks attached to one another, and the surface is here given as a smooth surface. That means no frictional force is applied in the bottom surface, and we have applied the force F in the block B. The mass is given, m1 and m2 is given. The question is given for sliding the block A on B. For sliding the block A on B, a horizontal force of 12 Newton is required. 12 Newton is required to slide the block A on B. How much maximum horizontal force can be applied on B so that both blocks A and B move together? Also find out the acceleration produced by this force. So this is an extremely important question. You have to know how to solve, what techniques should we apply to solve this type of question. Here you have applied the force on block B, not on A. The first information given as that you have, if you apply 12 Newton, the block A will slide on block B, that is it will move away. Now the question required is you have to move both the blocks together. So then in order to satisfy that condition, how much force should be applied to move block A and B together in the right hand side? See here we have applied the force 12 Newton, it is given 12 Newton. So force applied on block A is 12 Newton. Now this force must at least be equal to the kinetic friction applied on A by B. A by B, kinetic friction on A by B, that means B, the block is moving in the right hand side, so the kinetic friction would be in the opposite side. So this kinetic friction should be equals to this 12 Newton. Now 12 equals to that kinetic friction Fk. Now F equals to, we know, mu into r. Now what is r? R is your, this is m1g, so this would be your r1, let us say r1. So r1 should be equals to m1g. Now 12 equals to mu k into m1 is given as 4 kg, so 4 into g, g is 10. So mu k would be 12 by 4g, that is 3 by g. Now see, now we can move forward because we now know the kinetic friction force mu k, coefficient of kinetic friction, that is mu k. Now the block B is on smooth surface. Here we can see that block B is on smooth surface. So to move A and B together, the maximum force that can be applied on B is equal to the frictional force applied on A by B and B by A. Those two frictional force should be equals to this force. So this force should be mu k into r1 plus mu k into r2. So r1 is your m1g, r2 is your m2g. So that force, this force should be equals to mu k into r1 plus mu k into r2. Thus frictional force should be balanced with the applied force in order to move that object together, A and B. Don't slide. Here sliding is not, sliding should not be done here. So mu k m1 plus m2, you know the value of m1 and m2, put, you will get 27 Newton. Now see, as the blocks, two blocks are moving together, so that means they have common acceleration A. So what would be the total acceleration? Force equals to mass into acceleration. Now mass is total mass, that is m1 plus m2. So acceleration should be F by m1 plus m2, that is 27 by 4 plus 5, that is 3 meter per second square.